For more on that bridge collapse, Julian Carter, civil and structural engineer and director at By Julian Limited, joins us live from Leeds in the UK. Mr. Carter, thank you so much for your time. Looking at this incident, this was quite a shocking accident. Were you surprised by how quickly the bridge crumbled?
Sadly, no. It's a very, very lightweight structure. It has very long spans and it's lightweight so that it can have those spans. And given that ships of this size, they weren't around 50 years ago when this bridge was designed. So it's collided with one of the main supports. Now, you have to understand that this is a truss structure. Every piece on this bridge is working very, very hard every day. And it's continuous end to end. Everything is relying on everything else. So that ship has hit the pier. It's hit one of the main supports. Now, we cannot sit in plan looking down on the bridge. And what it's done, it's pushed that pier over as well. So really, the whole bridge is turned to one side and literally collapsed very quickly. There's a word we use, and it's called redundancy. To get that bridge light and get big spans, it has as little material in it as it can, and this is what happens when they catastrophically collapse.
Mr. Carter, authorities had insisted that the Francis Scott Key Bridge was up to code before the bridge collapse. Don't bridges usually have some form of protective measures around it in the water to prevent such an incident like this?
Yeah, to put fenders or fendering, be it mechanical fenders that are rubber shock absorbers effectively, or you put that pier within an island. That's a decision on expenditure from 50 years ago. It would be to code. It was designed for codes and standards of 50 years ago with steels that were in common use 50 years ago. And so now you also have administrative systems, i.e. the pilots that are on that boat. So you would reasonably expect that you have measures in place to manage that risk. And that is by having the right people on those ships, guiding it to the right locations. And unfortunately here, those systems have failed for some reason. But ultimately, it's a huge extra cost if you were to design that pier for a full collision like this. Obviously, 50 years ago, it wasn't considered credible.
Maryland's state governor says the container ship issued a Mayday alert before the crash, saying that it had lost power. Was there anything that could have been done to stop that impact?
When ports and harbours are designed, those similar structures that are protective are generally there for berthing. So the ship will enter the harbour in a particular way, it will slow down. There will still be energy. You can imagine the water and the way it works around a vessel as it berths. It is a big, big design to accommodate these sort of loads head on. It makes your structure, let's say, prohibitively expensive. It becomes far more expensive. And bearing in mind, we don't generally what we call retrospectively. Our design codes and standards will be different today, but national infrastructure is not viable if we have to start bringing it always up to the current standard, we just couldn't. No nation could afford to keep rebuilding all its critical national infrastructure.
You mentioned that because these bridges are built decades ago, but we've seen, like in the shipping industry, these container ships have almost doubled in size. So why have we allowed that? Haven't we considered the potential safety issues based on having these large container ships pass by these bridges?
I think in some ways we've allowed the technology to advance and advance and advance, and we've been seeing the problems in the Suez Canal where the ships have accidentally blocked the waterway, and maybe we are at a point where this accident now will make many ports, harbours, governments reassess their structures for such collisions, because if that boat was not under control at the time, then on a risk-based analysis, which is something we would do for a nuclear power station, we'd say, well, what is the frequency? What is the risk? And here, this risk is very, very high. And I liken it very much to the wall at Fukushima. Someone decided that the wall would be too expensive and the risk was low, but the consequence of that hazard actually occurring is huge. And I think here it's proved a point, and I think we'll see some very interesting and very deep-rooted findings from the FBI and the other authorities.
Yes, so authorities are still investigating the cause of this accident. What exactly will they be looking at? From your assessment, do we know if this is a case of human error?
I mean, I can't. I'm not qualified in the maritime environment. Although obviously the pilots will have to be breathalyzed. What is their state? Drugs and alcohol. But in terms of that structure, it is possible to look at the failures, look at the key structural elements and how they've failed. And one important thing here is we're not looking at temperatures that are -10, -20, -30 degrees Celsius. So the issues that we had in the 1960s, 70s of brittle failure, we shouldn't be looking at that. But it's not until engineers have done forensic assessments on the structure will we understand if it failed under too low a load, and that's an academic exercise that now will be undertaken.
Thank you, Mr. Carter, for sharing your insights. We were speaking to Julian Carter, civil and structural engineer and director at By Julian Limited from Leeds in the UK.